Assistant Professor in SNS College of Pharmacy and Health Sciences in Department of Pharmaceutics. We have already discussed the classification of complexes in previous classes, and now we are going to see the continuation of classification of complexation. Now, organic molecular complexes. Organic molecular complexes are the many organic complexes are so weak that they cannot be separated from their solution as a definite components. The energy of attraction between the constituents is probably less than 5 kg per mole for most organic complexes. Because the bond distance between the components of the complexes is usually greater than the third a covalent link is not involved. An organic coordination compound or molecular complexes consist of constituents held together by weak forces of the donor acceptor type or by hydrogen bonds. Donor acceptor type in this bond is between uncharged species but lacks the charge transfer. The type-dipole interaction and latent dispersion forces make the complexes stable. Example: the components dimethylamine 2,4,6 nitroanisole react in the cold to give a molecular complexes. The charges transfer complexes in this one molecule polarize the other, resulting in a type of ionic interaction or charge transfer. And these molecular complexes are often referred to as charge transfer complexes. The resonance makes the complexes more stable. The intramolecular bonding is quite higher compared to donor acceptor type complexes. For example, the polar nitro groups of dinitrobenzene induce a dipole in the radii. Caffeine and other drug complexes, drugs such as benzocaine, procaine, and tetracaine form complexes with caffeine. A number of acidic drugs are known to form complexes with caffeine. Quinohydrin type. The molecular complex of this type is obtained by mixing alcoholic solution of equimolar quantities of hydroquinone and benzoquinone. Next one, polymer type. Many pharmaceutical additives such as polyethylene glycol, that is PEGS, and carboxymethylcellulose (CMC) contain a nucleophilic oxygen. This can form complexes with various drugs. Example polymers: carbovaxes, fluoronics, etc. Drugs: tannic acid, salicylic acid, phenols, and etc. And carboxyl methylcellulose plus amidafine is a poorly absorbed drug. Picric acid type. Picric acid, being a strong acid, forms an organic molecular complex with weak bases, whereas it combines with the strong bases anesthetic activity of butazine to yield salts. Inclusion complexes. The complexes are also called occlusion compounds, in which one of the components is dropped in the open lattice or gauge like a crystal structures of the other. Channel types. Channels are formed by crystallization of the ghost molecules. The guest component is usually limited to long, unbranched straight chain components. Layer type. Components such as clays, montomorelinate, constituents of bentonite can entrop the hydrocarbons, alcohols, and glycols. They form alternate monoatomic layer of guest and host. Their uses are currently quite limited. However, this may be useful for catalysts on account of a large surface area. Clathrates, it is available as the white crystalline powder during crystallization. Certain substances form a gauge like a lattice in which the coordinating component is entropped. Monomolecular type inclusion compounds involve the entroppment of single guest molecule in the cavity of one ghost molecule. Most of the ghost molecules are cyclotextrins. The interior of the cavity is relatively hydrophobic, whereas the entrance of cavity is hydrophilic in nature. Applications of complexation: physical state and validity, and then solid state stability. In physical state, complexation process improves processing characteristics by converting liquid to solid complex. beta cyclotextrine complexes with nitroglycerin. Volatility compensation process reduce the drug volatility for following benefits: stabilize the system, overcome unpleasant odor. That is 12 complexes with polyvinyl pyrrolidine (PVP). Solid state stability. Complexation process enhance the solid state stability of drug. Beta cyclotextrine complexes with vitamin A and D. Chemical stability. Complex formation inhibit chemical reactivity, that is mostly inhibit. The hydrolysis of benzocaine is decreased by complexing with caffeine. Solubility complexation process enhance the solubility of drug. Caffeine enhance the solubility of para amino benzoic acid by complex formation. In dissolution, it's a process enhance the dissolution of drug. Beta cyclotextrine increase the dissolution of phenylpropitone by inclusion complex. Partition coefficient. Complexation process enhance the partition coefficient of certain drugs and permanganate ion with benzene. Absorption and bioavailability. Complexation process reduce the absorption of tetracycline by complexing with cations like calcium, magnesium, and aluminium. Complexation process enhance the absorption of indomethacin and barbiturates by complexing with beta cyclotextrine. Reduced toxicity. Beta cyclotextrine reduces ulcerogenic effect of indomethacin, and beta cyclotextrine reduce the local tissue toxicity of chlorochromosine. Antidote for metal poisoning. British anti-libestate reduce the toxicity of heavy metals by complexing with aluminium, mercury, and silver. Drug acting through metal poisoning. 8 hydroxyquinoline complexes with ferric exhibit greater anti-malarial activity. Anti-tubercular activity. Para-amino salicylic acid complexes with cupric ion exhibit greater anti-tubercular activity. Development of novel drug delivery system. The composition of drug with polymers used in the formulations of certain drug delivery devices. Assay of drugs. The complex matrix titrations are used to assay of the drug containing the metal ion. As a therapeutic tools, both citrates and EDTA are used as a preservation of blood as an anticoagulant. As a diagnostic agent, Da90 complexes with citrate are used for diagnosis of kidney and measurement of glomerular filtration rate.